and welcome to EtherCAT's Automation1 version 2.4 motion control platform release update. EtherCAT is a company that solves your toughest precision, motion, and automation challenges. Automation1 is a motion control platform consisting of software-based controls and development tools, PC and drive-based control hardware, and hardware-based drives for servo motors and other devices. In this video, you will discover new features available in the 2.4 Automation1 release. These features include work offsets, EtherCAT Distributed Clock, official Python API support, new API features, a task modal status interface, open loop tuning tools, machine controller definition file interaction improvements, controller feature improvements, plotting improvements, servo tuning improvements, helper module improvements, a new improvement to the MachineApps HMI builder tool, such as new designer tools, a new indicator feature, and module improvements. Also gantry improvements for improving how you configure non-standard gantries. Additional improvements also include 3-axis PSO support on the GL4, BIS absolute encoder improvements, and drive data capture and autofocus improvements. My name is Patrick Wheeler, and I'm a product manager for EtherCAT. Let's start off with beta features, work offsets, and EtherCAT Distributed Clock. Work offsets allow you to program motion relative to a fixed point. There are going to be over 100 work offsets available in Automation1. And if you can tell from the image to the right, the machine area consists of 4 different work offset points and a machine 0 point. You can again go up to 100 different work offset points in this new beta feature for Automation1. These work offsets are available across all controller tasks. So you'll set them in one task, but they'll be available to all controller tasks. If you're using the G-code programming language, there'll be 6 that are natively supported. And you can find out more in our help files under motion functions and G-code programming. So in the image on the right, again, the darker gray areas represent maybe a piece of substrate that you're working on. And then the lighter gray, larger area would be the XY machine space that you're working in. So you might have a program that's developed relative to the substrate, not relative to the machine working area. You would just apply that work offset so that all your motion commands would be relative to this fixed point in space. You can see how that works programmatically. You essentially home your axes and configure your work offsets, not necessarily in that order. And then you would enable that work offset with a G54 through G59 command if you're using G-code, or this new AeroScript function called work offset enable. Then if you disable it, just using the G53 command in G-code, or the work offset disable in AeroScript. And if you want to suppress the work offset for a time being, but not really disable it, you can do that. You can make motion commands inline while a work offset is active by issuing a G153, then issuing your move command, which should take you back to machine 00. It would not take you back to your work offset 00. So it's really quite a simple concept, but really, really important and powerful for people that are running parts on substrates within a larger machine working area. EtherCAT Distributed Clock is the next beta feature that was added in the 2.4 release. This enables master and slave devices to share the same system time to a nanosecond resolution. The master basically queries slaves periodically to determine drifts and adjust accordingly. In Automation1, as you can see, the XC4E, the iXC4E drive, here connected in the EtherCAT yellow bus network on the image on the right. This allows the hyperwire network, which that iXC4E drive is managing, to be externally synchronized to other devices on the EtherCAT network. This guarantees a round-trip latency between, say, a Beckhoff TwinCat3 EtherCAT master and the Automation1 controller. It's really good for allowing our Automation1 motion controller to live within a larger automation environment managed by EtherCAT. EtherCAT Distributed Clock, status items are in the status utility. This is a very nice thing to know and a very nice place to go to do some diagnostics if you need to. We'll tell you the configured signal, which is the external signal for hyperwire synchronization. Its frequency, is it active? Is that synchronization active? What is the detected frequency? Is it different than the configured frequency? What is the synchronization lagging? Is it lagging behind? And is there an adjustment being made? So this is where you go for all of that diagnostic information. Let's talk about the new non-beta features, the new official features. First off is official Python API support. The Python API can connect to the Automation1 controller to get status, execute commands, run your process, and much, much more. And really much, much more. So please check out our Automation1 Python API help files, which are live on the internet right now on help.aerotech.com/automation1 to really find out the full spectrum of what's available in Python. The Python API is distributed with the Automation1 Motion Development Kit, which also installs Python example programs. And again, the complete Python API help documentation will be installed locally on your computer, but it's also accessible via help.aerotech.com/automation1. So please check that out for a full listing of information. We support Python version 3.8.10 and newer. And we also support the following operating systems: Windows-based operating systems, Windows 10 or newer, 32-bit and 64-bit. And also Linux Debian 10 64-bit is supported, but any 64-bit Linux operating system with GLIBC 2.28 or newer and GLIBC XX 3.4.25 or newer might work, but it's not officially supported. Okay, so you can try it, but not officially supported. New API features in general include, if you're somebody who writes data to the drives for certain process requirements, the new drive array write functions, new overloads are faster, and they do not use a controller task to work when you're using them from the API. So that's a clear advantage for writing data to the drive array. And also in .NET, you can now compile a controller file as an AeroScript source file, but with the debug information, which is also very useful to have. Moving on, in the application, we now have this new task modal status information, which exists in the Automation1 Studio underneath the develop workspace in the task status module, which is part of a module container that also includes the variable and IOs and program automation modules. So if you click on task status, you'll get that module to view in your Automation1 Studio develop workspace, and you'll see there's added task tabs, not just the overview tab. So task 1 now shows all of your modal statuses, including the task 1 status, which in this screenshot is program paused on motion and program line 13. And then all the different modal status items are displayed, including your different motion modes, acceleration modes, distance and velocity modes, target programming mode, velocity profiling mode, your weight mode, your cutter comp mode, and also your spindle shutdown mode are all available here. And that's really great when you're doing development work and you want to know whether or not you're in the right programming mode for the type of application you are programming. A new tool called Open Loop Tuning has been added. Most people won't need this, but it's available. And the reason that it's there is to obtain a stable set of servo gains. This is like the I'm lost in the woods and I need to find where the path is, getting yourself out of trouble tool. The servo gains are optimized via iterative tuning, open loop tuning process, or you can actually, after doing this once, open loop tuning once, you can jump into other tuning methods, okay? And the process that really goes on here for open loop tuning is we inject an open loop current into your motor. So in doing that, we present you this nice warning label saying, are you really sure you want to do this? Make sure your hands are clear. This will cause motion. If the stage is underneath the effects of gravity, this can be bad for you to do. So this is really an expert level feature that is there, but it helps make the controller more versatile in situations where tuning might be difficult. And what you really get out of this is a set of suggested gain values to set to your controller and would help you maybe move forward to the next step of servo motor tuning. All right. So if you can imagine you're trying to tune this servo motor and you're just not getting anywhere, this could be useful for what you're trying to do. And there's also plots that are generated to help you evaluate the motion that just occurred. So that is the open loop tuning tool. Next, there's a series of improvements I'd like to go over. The first one is your MCD file interactions, the download manager. That tool has been there for a while, but I'll talk to you about this as a precursor to the upload manager, which is a little bit more robust than it was before. When downloading a machine controller definition file, you now have flexibility to download the complete controller backup, which we always did, or simply select the portions of the controller configuration that you wish. So one place where this has come up recently is if you just want to take your machine apps or your HMIs that you developed from one controller to the next, you can simply select the machine apps and that's all that you'll download to your MCD. Then when you go to upload that on the next controller, you can just upload that and start working from there. The location of this is in the Automation1 studio, in the configure workspace under controller administration, and simply click download MCD and this user interface will appear. Moving on to the upload manager, when you're actually uploading a machine controller definition file onto your controller, this is when you can upload the full controller configuration and all controller files, assuming that the MCD you're uploading has all that information. Going back to the download manager, you don't have to download all of those things. So if it's not there, you can't really upload it to a new MCD file. But assuming it's all there, you can upload the full configuration of your controller, which really helps people duplicate their machine controllers when they're deploying multiple machines, as a machine builder. You can also upload the parts of the machine controller definition file that you desire. You can make choices. And the location of this, again, is in the configure workspace under controller administration, where you click upload MCD. And the process that you'll walk through here, first there's an MCD configuration step. You click upload or skip for all these different parts of the controller configuration, including the name, the startup settings, the hyperwire, bus settings, access control settings, parameters and machine setup configuration, program automation, and also your machine apps. You can choose to upload or skip all of those things. In the next screen, you can also choose to, on your existing configuration, say your controller is already configured and you're changing it, well, you can choose to retain or delete your hyperwire, your access control, or your machine apps. So that doesn't mean you can't also upload other machine apps, but now you're getting the choice whether to actually delete what's there already. So as you can imagine, there's 4 different choices on machine apps. You can retain your current and upload new and not retain current and not upload new, or not upload new and not retain the current, which would just wipe out everything. So you're going to get to a summary screen on all of that here in a minute. For the controller files, the same thing goes. You can retain your current controller files and upload all of the new ones from the MCD you're uploading. Or you can say, I just want to delete what's there and upload only the new ones. Or you can basically upload the new ones and not delete what's there. So there's tons of choices for you to make in this process. And finally, at the summary screen, you can see all the different choices you made, and you can see exactly how the current controller configuration is going to be changed. Because in Automation1, every controller needs to have an active machine controller definition. So although off the controller, the machine controller definition is sort of a file, while you're working on a controller, it really is the definition of the controller. So this is what you're doing to overwrite your current controller and change the way it's configured. That's what this upload manager is doing. You see the summary screen. You can choose to either finish and complete this configuration of your controller. You can go backwards and change things, or you can just cancel and back out of this completely. But what you can't do is recover the changes once you click finish. So make sure you're sure of what you're doing and then complete this task, and you'll be able to move forward with your new controller configuration. Listen, this makes all of the flexibility of the MCD file accessible to you, the user of Automation1. We continue to make improvements in the application. This page highlights some of the plotting improvements, specifically the fast Fourier transform. We added this option to calculate the Fourier transform on only the data that is either visible in your zoom setting on your 1D plot, or the data between 2 cursors on your 1D plot. So instead of taking the full spectrum of the full data set and always doing the fast Fourier transform on the full data set, you can limit it and focus in on a specific area, which is sometimes very helpful in troubleshooting if you see some frequency of error around a corner that you want to evaluate. And the output of it is what you kind of see tucked behind that first image with the red line there is a fast Fourier frequency domain plot of the, in this case, the position error. There's also plotting improvements, plot scaling. For your signal units, they can be displayed as primary, secondary, or counts, and they can be scaled as an arbitrary factor. So you can take your counts and divide or multiply them by a scale factor, and that's going to show up in your data visualizer. You can also take your time units and display them in seconds, milliseconds, or minutes. Again, that'll change the way they display in the data visualizer. And then finally, for the 2D signals, you can have user-specified labels, scale factors, and offsets, which you see right here in the image. You can specify your scale factor, your offset, then change the label for something like this, like the position command. Now here, the POS CMD, that's your default label, but you can rewrite that to make it whatever you want it to be. Continued plot improvements. You can see here you're actually rewriting the label. So for plot signal labeling, default labels have been provided for all the signals, and those match mainly what you see throughout the application. You can also do these user specified labels, and again, that applies a non-default label which can be specified for any signal except the status item signals, which are larger word signals with multiple bits underneath them. Those are a little bit different, but for almost all signals, you can rename the label, which will change the way that it shows up in the actual plotting portion of the data visualizer. I like to bring up these user safety things when I see them come around. It's important to know that, Aerotech software engineering and hardware engineering teams are always trying to make it such that users don't make any mistakes when using the application. So we basically added a confirmation prompt when exiting the configure signals dialog with any unsaved changes. So you might notice this if you're somebody who uses Automation1 quite often, that we're just trying to make it so you can't leave without saving your changes and then go and try to collect data and wonder why the configuration wasn't applied. It saves you a little bit of time on the back end by confirming this on the front end. Additional plot interaction improvements, time-stamped plots. This has added a timestamp to unsaved plots in the data visualizer that indicates when the data was actually collected. So you might take a look at this and might give you some insight to when did I collect that plot? How long ago was that one from? That gives you some added insight as to when that plot was actually collected. We also added some more tooltip information. So if you hover over the plot tab, it'll show the file's location on disk and the last time it was modified. Again, just giving you more insight to the tools, to the things that you're working with every day, trying to be more sensitive to users and the context they might need around their data. Talking about servo tuning improvements, manual servo tuning, it's a feature that's existed for several releases now. We guarantee that the displayed gains are the active gains for when the plot was created. You can go and change those gains still, but when they're first displayed, those will be the ones that are active when the plot was created. The frequency response and manual servo tuning tools now say that any changes in gains, servo filters, and enhanced tracking control parameters don't carry over to other plots. So if you're in there on one plot and you're working on gains and you're working on servo filters and other parameters, and those are all down in the bottom toolbar here, when you change maybe from plot 7 to plot 6, those changes are not going to show up in plot 6. They only apply to the plot that you're actively working on, which is going to make it far less confusing if you're switching between plots. Like, well, I made changes on plot 7, but what were the gains at when I took plot 5? How is that different? If you want that context, it'll still exist. And again, just another user safety item, during frequency response measurements, the studio now immediately stops measurement if an access fault occurs. So that's a pretty obvious one, but that's in there now. In the homing helper module, for longtime Aerotech customers, this is probably one of the more innovative, nice features that we added a few release cycles ago while we continue to make it better. Now, those user safety things here in the homing helper module, which helps you set up your home routine for an access. Now we clearly recommend a home type. And we warn you if the home type parameter has not yet been set. So if you've never actually gone through and do this, you'll see that little orange triangle with the exclamation point saying, warning, warning, you have not done this yet. And then we also will indicate if a reverse motion direction is enabled. We've also added belt drive support. So any of the belt drives that we now have supported in machine setup, which are some new products to hit the market, we can set those up with Automation1 as well. We also have some user input feature here at the bottom where you can actually rotate a stage to desired home location and just click OK when you're at that position. And that's to help set up home offsets and things such as that. Again, the homing helper module is really great. It tells you things like what your home speed is going to be, what percentage is that of the max jog speed parameter, how long, if you have a home to limit, reverse to marker, homing type, we will estimate how long it'll take you to run a home cycle. So we just trying again to be more cautious of what users would like to know when they're doing this type of configuration. Let's jump into MachineApps. MachineApps is turning into quite a big software feature for Aerotech and quite a good opportunity for machine builders worldwide. Now, MachineApps, which allows you to build custom machine control HMIs or applications for say like an operator or like a technician who has to interface with an R&D machine, industrial machine. It allows you to display that HMI. So please look at previous product trainings. There is a MachineApps overview available on YouTube and available on aerotech.com. Check that out to learn more about MachineApps. Things that we've added on the designer side is this idea of module containers. So if you look here in the light gray screen, you'll see a jog pad and a task status in this one kind of square rectangle looking area. That's because that area has been changed from just an area that contains one module, like say the one on the right that just contains a programming module, to one that can contain multiple modules. So that allows you to put a tabbed user interface into your machine HMI tool, and you weren't able to do that before with this tool. We also have this drag and drop modules. This screenshot here is how that tab would look actually in your HMI. So as you can see, the jog pad is over on the left, and if you click on task status, that's a completely different module that would show up in this same real estate. If you're working in the designer tool, you can now drag and drop modules between the different spaces. So if this was blank, or you can see here, I'm kind of dragging the customizable buttons and indicators from the right-hand side to the bottom, and just click on it and drag it right down. Makes it a lot more flexible for developers. We also added this new feature called indicators. Indicators are now added to the customizable buttons and indicators module inside of a machine app. So when you're actually going in and programming or developing your machine app, in the same user interface, you can add your custom buttons that actually call on custom machine functionalities, and also indications which tell you things like, in this case, the machine is moving. And that machine is moving bit is activated by a conditional statement. We actually track a virtual binary output bit 0. And when that goes to high, that's indication that the machine is moving. Now, what you're not seeing is on the back end of this machine control, there is some custom logic being run like a PLC task that is constantly monitoring axis motion. And when axis motion happens, it sets that bit to 1. So we're doing that in AeroScript, in the programming language. And then this indicator is kind of playing off of that logic and changing the way it looks to a user based upon the status of that virtual binary output. Important here that indicators are read-only. They're rectangular status displays. You cannot push them. If you want to push something and have functionality happen, that's where the customizable push buttons come to play. And they sit side by side with indicators in this module now. So you can actually build a UI that has both. Now, indicator control it can be based on these state things like we're doing in this example, but it also can be done via AeroScript functions, which you can find in the help files for application indicator control. So there's multiple ways to take control of your indicators. The customizable buttons are just generally improved above and beyond having indicators. The display buttons and indicator based on state automatically select a specific button and indicator page based upon a system, axis, or task value. So that was a mouthful. What do I mean? I mean, the display page can be changed based upon some state of, for in this example, I'm using a global integer. And when that global integer is set to 1, we're going to display the operator control page of push buttons. When that is set to 0, we're going to display the auxiliary equipment control, which is another set of push buttons that will actually be displayed. So this is building more of like a state machine logic into your HMI, but only really changing the listing of push buttons and indicators, changing your full HMI page based upon a state, but changing part of it. You can copy a state when you configure customizable push buttons. So here you'll see the push button editor. I'm actually editing the push button name phone screen. And I have 4 different states that are defined here. One is an inhibited state where the push button cannot be operated. And 3 more ones that are non-inhibited states. One operates a special screen, one is a copy of that special screen, and one is the phone screen. And you'll see there's a little copy button here for copying that over to a new push button. And then it has a very nice preview that shows you exactly the way it's going to look in your HMI based upon your background and foreground colors. And you can see that in this state, when you push this button, you're going to trigger AeroScript command screen 1, which is a custom library function developed by a user using the AeroScript library's capabilities. And this whole entire MachineApp's customizable buttons and indicators screen received an improved layout in the 2.4 release. The Jog Pad also was improved in 2.4. Now, instead of being limited to just simply one jog pad, knowing that many systems include many sets of different XY axes of motion, or maybe a Z axis that's on a bridge, we now allow you to configure a maximum of 3 axis sets in the Jog Pad module. And here you see that we're able to jog 5 axes in combination on one screen. You have the XY, you have the Z, and then you have, in this case, a laser scan head, which is listed as your C and D axes. Now, each one of these jog pads, it's not shown, but you can add diagonal push buttons for jogging other axes. So each jog pad can actually jog 4 axes. So 4 times 3 means you could have up to 12 axes of jog control in one jog group. And then, of course, if you have more than 12 axes, you can add additional jog groups to get to those. So it makes that a lot more flexible, and a lot more control is readily accessible to your users. The jog speed and jog type controls also have been put in this nice little menu bar at the top of the module. And if you want to see the settings in a table, just click on View Jog Settings and we'll display those to you as well. Moving on to variables and I/O modules. The variables and I/O module can now limit which tabs and favorite items show up in a MachineApp. And really, we kind of combined that capability with this fixed favorites option. So if you really only want to show a known list of variables and I/O points that you really care about in your MachineApp, we piggybacked off of the develop workspace where you actually go and create your favorite list. So you basically go and create your favorite list in the develop workspace. You come back over to the MachineApps workspace, you click on favorites here in the UI, and you click fixed favorites, and you click on copy favorites, and it's going to copy over your favorites from that screen. Now it says 4 here, configured favorites 4. That's just me taking screenshots. In this example, there's actually 7. It would say 7 there if it noticed that you had 7 favorites configured. And then you click that, and now your MachineApp HMI will always display these 7 favorites in this favorite tab. And if you click off all the variables and drive I/O and industrial Ethernet things, you can really build a variables and I/O module that allows you to focus on only the variables and I/O that your user should care about, and basically hide everything else away, which is sort of the purpose of doing it this way. There's more we want to do in variables and I/O, but this is a nice step in the right direction for the 2.4 release. Moving on to Gantry Improvements, and this is something I'm really excited about in Automation1. In Automation1, we implemented our Theta Gantry control. It's something new to the EtherCAT control platform, and seeing a lot of good successes with this, with these improvements, mainly from a user setup and configuration point of view. Let me show you what I mean here. Now, quick review of gantry control methods. First, we have what's called the decoupling control. This is really focused on superior dynamic performance and positioning accuracy. It is a high precision alignments and low error motions are required. And in this case, you can see that you're reading positions off of both of your gantry axes. We're calling them SPAR 1 and SPAR 2. And you're doing a multiple input, multiple output transformation called decoupling control on the position. And then you're actually entering a position control loop for 2 virtual axes or 2 calculated axes. We'll take a look at that in the next slide. And then you're creating control efforts to go back out to the SPAR 1 and SPAR 2 based upon those non-real axes that you're controlling. There's another gantry control method which is much simpler, but it's much better than, say, dynamic performance achievable if you were only controlling one SPAR. In this case, it's less demanding than decoupling control on the quality and complexity of the mechanical design. So maybe your 2 gantry axes are not rigidly coupled, but you can basically mirror out the current command from one control axis to the other motor. So that is a very brute force way of getting essentially more motor current into an axis of motion. But for the rest of this talk, we're going to be focused on this decoupling control setup of a rigid H-bridge gantry. Here you go in the bottom right, probably the first thing that grabs your attention are the bright colors here. Let me walk through the text on the left and give you an overview of what's going on in our device catalog and machine setup support for gantries. First of all, Aerotech deploys custom gantries, so we needed to do this tool to make our custom gantry deployment much easier for our manufacturing people and much easier for our systems engineers who are working with them to deploy gantries. The benefit that to our general user base is it's going to be easier for everyone, right? So in a tool we call a device catalog in Automation1 Studio, you go through this process of naming and describing the gantry device. You either manually specify or copy existing device settings. And here you see in my example, I'm working off an Aerotech AGS 15000 gantry, and that ES12345 designates a special build of the AGS 15000 gantry from Aerotech. So we're working from a base device, which is a standard Aerotech product offering, quite possibly one of the, I'll walk back on that. It is the leading gantry in precision motion control available to buyers. So if you're interested in gantries, you're already in the right place if you're talking to Aerotech. And then you would enter the gantry device specifications, including, as I said, the control method, decoupling control, or current-based gantries, top-level specs of the gantry. You'd actually enter specifications for your logical axes, what I may be called virtual. Logical axes R and theta specs. So even your non-real motor axes get specifications. And if you look at that image in the bottom right, you can see that green R is your linear axis of motion, which is programmed to be virtually right down the center of that gantry where there is no motor. And then also your theta axis of rotation, which again, there is no rotary motor here on this gantry, but theta is basically a combined motion of spar 1 and spar 2. So spar 1 and spar 2 are your left and right gantry axes connected by the bridge axis. And you set up all the specs for those axes, including what kind of motors you have, what types of feedbacks you have, and a various other set of specs, the length of travel, the separation distance, the feedback separation distance between these two spars. Those are all questions that we walk you through step by step in the device catalog. I'm not going to show you all those steps because we need to do a standalone gantry training for everybody, but pretty much you can believe that this is a wizard-based approach where we're asking you questions and walking you through that configuration. And our engineering managers that are doing this now, configuring gantries, I'll say 10 minutes to configure a gantry. I've seen them do it in less. I can see them doing it in less than 10 minutes, 5 minutes to set up a full gantry from Aerotech, which is going to help us, ship gantries, but it's going to help customers worldwide build gantries with the Automation1 controller, which I'm extremely excited about. Inside of machine setup then, after you're done with actually specifying that gantry in our device catalog, in machine setup, you're going to use that device you specified. So first you're going to go through and ensure that all of your electronics, your drives are added as electrical devices. So for a gantry, you're going to need 3 drives for that. And again, in Automation1, going back to this decoupling mode of operation, we can use multiple single axis drives to control a 3-axis gantry with spar 1, spar 2, and bridge without any additional cabling. So our hyperwire network is so fast that all the information for the multiple input, multiple output control mechanism you need to do can all go over hyperwire. It's very easy to troubleshoot in the field because you're not chasing down tons of encoder data, traveling copper to copper from drive to drive to drive. It's basically like building a drive rack out of single axis drives. Now you can use our XR3 drive rack as well. You would use 3 axes of motion out of the 6 on that rack, but you can also control gantry with single axis drives from Aerotech. You add the gantry as a mechanical device, and then when you go into what's called the interconnectivity screen of machine setup, is where you connect those spar 1, spar 2, and your bridge to these 3 electrical devices. It's very quick, it's very easy. I know that it almost takes longer to explain it than to do it. Other things in Gantry Improvements, if that wasn't enough, and please call us, ask questions, reach out to your local field sales engineer. Something that people are going to want to be aware of, this new Gantry Improvements. We also have absolute encoder support on gantries. So in your primary feedback, it can now be an NDAT absolute encoder, either with incremental signals or without. And on the auxiliary feedback of a drive, the gantry can now work with an NDAT absolute encoder without incremental signals only. So the primary supports with or without, and the auxiliary only supports without incremental. And finally, if that wasn't enough on Gantry Improvements, we also added gantry support to these multi-axis drives. And you'll say, well, Patrick, you just told me the XR3 is a multi-axis drive and it supports gantries. Well, that's true, but the XR3 is unique in that it's a multi-axis drive, but it has single axis architecture for each axis, right? So the Xi4 is unique in that one host controller on the board controls multiple axes of motion. We did that because the Xi4 is a cost-effective device that's required for lots of people doing motion control with EtherCAT. All right, and then the Xi4 is also meant to control other amplifiers that take an analog input for their control. So we put out a plus or minus 10 volt signal and control third-party amplifiers for the Xi4 and the iXi4. So now you can do that all on one box. Will support this MIMO decoupled based gantry control. So for you being a machine builder out there, you can take an Xi4, and let's just focus on this one, the blue one, which is the iXi4. This has the full Automation1 motion controller configured and runs on here. So this is PC-less control. No PC required. You just connect to it over Ethernet. You can use our APIs, our Python, our .NET APIs to talk to this iXi4. And the iXi4 can control up to 4 axes of amplifiers, meaning that you can create 2-axis SPAR1, SPAR2 gantry with a bridge. That's 3 axes, and even add a Z-axis to it, all from this one device from EtherCAT. It's a very cost-effective way of controlling a gantry. Now to go over some additional improvements in the 2.4 release. First, we'll talk about GL4 now supports 3-axis PSO. This is important because we're doing more multi-dimensional laser scan head applications. This would be key for laser scan heads where you're actually traversing a non-flat surface and you want to use PSO across that surface. PSO is unique in that it's using actual encoder data. This is not trying to follow a fixed velocity or maintaining constant velocity in your motion to obtain, equal pulse spacing. This is actually counting encoder pulses, doing a vector calculation on those pulses, and using that vector math to actually maintain spacing. It's a very direct, very well-known in laser industry and very successful method of controlling spot-to-spot placement of industrial lasers. So if you're not familiar with PSO already, please reach out to your local sales guy. This is something you probably want to know about. It's also used in applications such as big science, synchrotrons, where you're actually using it to trigger data capture based upon position, not control an industrial laser. You can see from that image, when you're controlling the laser based on velocity, when you start to corner, your velocity changes significantly, and that laser pulse spacing starts to overlap. That leads to quality issues. Well, you don't want that. You want to know how many raw encoder counts have I actually traveled and control your laser based upon that. The next bullet item here is BIS improvements. We have multi-turn BIS encoder support. It dropped out of the presentation for some reason, but we also can support BIS encoders with incremental tracks now. That was required for ANT series linear stage EtherCAT cells. That is an absolute encoder based feedback device. We also have this new drive data capture. We can now capture position feedback at the servo rate. So that's a much faster way of capturing this data. And you basically write that into your drive array, your memory at your drive, and retrieve it later to the controller level. In autofocus, we added a target feed forward functionality to the autofocus feature. And we also added what's called the additive mode operation, which adds the autofocus output to the position command of an axis. And that's it. I know it's a lot for one release. It felt like a major release and a minor release, but we really hope you guys enjoy this. Please reach out to us with any questions you have on 2.4. This concludes our motion control platform release update. Thank you for watching. I hope you really enjoyed learning about all the new features which are available in the 2.4 Automation1 release.